Good evening, everyone. So, today we are going to discuss one more very interesting method to find a particular solution of non homogeneous second order differential equation. Here we assume that the second order non homogeneous differential equation is of the form y double dash plus py dash plus qy is equal to f of x, where p and q are constant. So, again, a very particular case, but the advantage of this method is that it is very quick. Once we will see the complete method, you will realize that using this method is comparatively very easy than the methods which we have studied. Also, in the case of undetermined coefficient, f of x has some restriction that it can only be a polynomial or sine cosine function or an exponential function. Here we will see that f of x could cover more general cases than in comparison to undetermined coefficient. So to begin with, let us assume that d by dx is denoted as capital D and d2 by dx square is denoted as capital D square. Then the differential equation y double dash plus py dash plus qy is equal to f of x becomes d square plus pd plus q is equal plus qy is equal to f of x. Now I represent d square plus pd plus q as a function of d. So I simply write p of d, which means a function of d, y is equal to f of x. And now what I do, I take p of d on that side, and that gives me y, which is a particular solution of the given differential equation. Things would be clear that how it works, but we'll first see two special cases which we are going to use very frequently. One is if p of d is equal to d. So what will happen if p of d is equal to d? So in that case, your y would be 1 by d f of x. So d is d by dx, which means 1 by d is simply the integration of f of x dx. Yes. And the other case which we will discuss is when p of d is equal to d minus r. So case 2, if p of d is equal to d minus r. Yes, in that case my y would be 1 by d minus r and f of x. If I take d minus r on the left hand side, so it gives me y dash minus ry is equal to f of x, which is a linear differential equation. So I can simply write down its solution: y dot e raised to the power minus r dx is equal to integration e raised to the power minus r dx f of x dx. Now r is a constant. Even we can mention here r is a constant. So since r is a constant, so constant means when we write down the auxiliary equation, you can see that we write it in the form m minus 2 m minus 3. So similarly we can write d square minus 3d plus 2 as d minus 2 d minus 1. So that's why r is a constant. So since r is a constant, e raised to the power minus integration r dx simply becomes e raised to the power minus rx and integration e raised to the power minus rx f of x dx. This is here, and if I take e raised to rx on that side, then my y becomes e raised to the power rx integration e raised to the power minus rx f of x dx. Okay, so these are the two important formulas, especially the second one, which we are going to use many times. So now we'll discuss various ways for solving differential equation. So for solving differential equation, so I will start with the first one. We call it successive integration. So what it suggests is that if I have p of d of the form d minus r1, d minus r2 and so on, and f of x, then I must consider one at a time. So d minus r1, then bracket 1, d minus r2 and so on, and d minus rn f of x dx. Okay, so very simple technique. It would be clear once we do few examples. So let's try the first example. So solve, let's say you have given y double dash minus y is equal to e raised to the power minus x. So first thing is, if I have to use the operator method, I should write down in the form of operator method. So it would be d square minus 1y is equal to e raised to the power minus x. That would become y is equal to 1 by d minus 1d plus 1 e raised to the power minus x. Now the successive integration says that I should handle one at a time. So this is, sorry, d plus 1. So 1 by d plus 1 e raised to the power minus x. So if I consider d plus 1, it means, if you remember, d minus r, so here r is minus 1, and that's why it becomes 1 by d minus 1 e raised to the power rx, so minus x, integration e raised to the power minus x, because e raised to the power, if you see here, then e raised to power rx, e raised to power minus rx. So e raised to rx is e raised to power minus x, e raised to the power rx, e raised to power x, and f of x is e raised to the power minus x and dx. I am simply using the formula. So if you substitute the values, then this will become 1 by d minus 1 and e raised to the power minus x integration dx, which is 1 by d minus 1 e raised to the power minus x and x. Now r is 1, so therefore it becomes e raised to the power x integration e raised to power minus rx, then x e raised to the power minus x dx. Now I simply need to integrate x e raised to the power minus 2x dx. So integration you can try it by yourself, and you will realize that it would be e raised to the power x minus x by 2 e raised to the power minus 2x minus 1 by 4 e raised to the power minus 2x. So this would be equal to e raised to the power minus x by 2 minus 1 by 4. Okay, so this method is known as the successive integration. Let's quickly try one more question based on the successive integration. So y double dash plus 4y dash plus 4y is equal to 10x cube e raised to the power minus 2x. Now you can see that it cannot be solved using the method of undetermined coefficients. The other thing is, if you use the variation of parameter, it will take lot of time. But if you use the operator method, then it would be very easy, because it looks like d square plus 4d plus 4y is 10x cube e raised to the power minus 2x. So it turns out to be y is equal to 1 by d plus 2 whole square and 10x cube e raised to the power minus 2x. So now r is minus 2. So I will take it to 1 by d plus 2, and other d plus 2 would go inside. So that becomes e raised to the power minus 2x integration e raised to the power 2x x cube e raised to the power minus 2x and dx. So this becomes 1 by d plus 2 e raised to the power minus 2x and 2x would cancel out. So e raised to the power minus 2x x raised to the power 4 by 4. Again r is equal to minus 2, so it becomes e raised to the power minus 2x integration e raised to the power 2x, e raised to minus 2x, x raised to the power 4 by 4 dx. So this turns out to be x raised to the power 5 by 20 e raised to minus 2x. So you can see that if you use variation of parameter, it will take a lot of time, but here you will be able to do it very quickly. The next method is partial fraction. So if you see the previous method and if you see this question 1 by d minus 1 d plus 1, so you can simply write it in the form of the partial fraction. So sometimes partial fraction can solve the problem more quickly. For example, if I see the question y double dash minus y is x square e raised to the power 2x. So this is 1 by d minus 1 d plus 1 and x square e raised to the power 2x. Now I can use the previous method successive integration also, but if I use the partial fraction, then it becomes more easy because I just have to use the operator method separately. So now this turns out to be, in the first case r is 1, so e raised to the power rx, then x square e raised to the power 2x e raised to the power minus rx dx, then minus e raised to, now r is here minus 1, so x square e raised to the power 2x e raised to the power x dx. Yes. So now it becomes e raised to the power x integration of x square e raised to the power x dx minus e raised to the power minus x integration of x square e raised to the power 3x dx. Now integration is quite easy. You can do it by yourself. And after doing it, please do match the answer. It turns out to be e raised to the power 2x divided by 27 and 9x square minus 24x plus 26. Yes, now I will discuss one more method. There are many methods which need to be discussed, but in today's class I will discuss only 3 methods. The method 3 is series expansion of operators. So series expansion of operators. So in this case I will consider a special case first when f of x is a polynomial. F of x is a polynomial. So I will use the following geometric series. 1 by 1 minus r is 1 plus r square plus this one, and this is 1 minus r plus r square minus r cube, and so on. You can ask one question is that if let's say I have 1 by 1 minus d and I use the geometric series, then you can discuss about the convergence because you assume that mod r is less than 1. But here we do not discuss about the convergence because our polynomial is of finite order. So that's why we are not worried about the convergence. Now let's see some question based on this technique. So the first one is y double dash minus 2 y dash or y triple dash minus 2 y double dash plus y is x raised to the power 4 plus 2x plus 5. So now if the right hand side is polynomial of degree 4, then you can realize that if you use undetermined coefficient, it would be a0 plus a1x plus a2 plus a3 plus a4. So you have to compute the value of 5 constants, which is tedious process. But if you see this technique, then here y would simply becomes 1 minus 2d square plus d cube x raised to the power 4 plus 2x plus 5. So I can write it as 1 plus, there could be many ways to write it down, and then raised to the power minus 1 x raised to the power 4. So now it is a geometric series 1 by 1 plus r. So if I expand it, then it becomes 1, first term is 1 minus r, so 1 plus 2d square minus d cube, then plus r square. So r square would give me the term 4d raised to the power 4, then minus 4d raised to the power 5, because multiplication of d square d cube, and the next term is d raised to the power 6. So even I do not need d raised to the power 5, so I am not bothered about the remaining terms, and x raised to the power 4 plus 2x plus 5. So now I am only worried about these 4 terms. So if I multiply by 1, then x raised to the power 4 plus 2x plus 5, then 2d square. So d square would work on x raised to the power 4 only, so 2 and 12x square, minus d cube again work on x raised to the power 4, so minus 24x, and 4d raised to the power 4, so 4 multiplied by 24. So it becomes x raised to the power 4 plus 24x square minus 20x plus 101. Yes, so you can see how easy it is to use the operator method technique in comparison to undetermined coefficient or the method of variation of parameter. Let's try one more question. 4y double dash plus y is x raised to the power 4. So my yp is 1 by 1 plus 4d square x raised to the power 4. So this would be 1 plus 1 by 1 plus r, so 1 minus 4d square plus 16d raised to the power 4, and other terms I do not require. So it becomes x raised to the power 4 minus 48x square plus 384. So in the coming class we have to see many other methods also, especially when exponential function is multiplied with sine function or sine function is multiplied with polynomial. So all these functions of this form can easily be addressed using the concept of operator method. Thank you very much.